Our final speaker, our wrap-up hitter, is Dr. Paul Wolpe, the Asia Griggs Candler Professor of Bioethics, the Raymond Shanazi Distinguished Research Professor of Jewish Bioethics, the Professor of Medicine, Pediatrics, Psychiatry, Neuroscience, and Biological Behavior and Sociology. We certainly, in our institutions, don't go for short titles. You can see this. And I'm not finished, right. The Director of the Center for Ethics at Emory University. Now that's brief. He also serves as a senior bioethicist at the National Aeronautics and Space Administration. Dr. Wolpe is the author of over 125 articles, editorials, book chapters in sociology, medicine, and bioethics, and contributed to a variety of encyclopedias on bioethical issues. He's editor-in-chief of the American Journal of Bioethics, Neuroscience, a past president of the American Society for Bioethics and Humanities, fellow of the Hastings Center, and a fellow of the College of Physicians of Philadelphia. Welcome, Paul.
Well, thanks very much. The danger of going last may be redundancy, but I hope that some of the redundancy is seen as reinforcing and validating ideas that I think other people have articulated that are very important. I believe there's no more topic more important to think about right now, educate ourselves about, and in some areas control actually through legislation, the emerging powerful technologies of neuroscience. I'm a sociologist trained in social psychiatry, so I always had an interest in the functioning of the brain, but I started my career working on genetics and had a kind of epiphany when I realized that the things that we were so concerned about in genetics, genetic privacy, human enhancement, misuse of technology, we're decades away in genetics, at least in human beings. We're not going to be enhancing human beings genetically anytime soon, but we're happening already in neuroscience. We're already enhancing ourselves neurologically in a variety of ways, and technologies are coming down the pike that will give us enormous power in that area long before we'll be able to genetically enhance human beings. Or if you take the example of genetic privacy, we've worried a lot about genetic privacy over the years and have legislation on genetic privacy. But the real bottom line of genetic privacy is, first of all, I don't really care that much if you have my genome. There isn't really that much about me you'll be able to tell. It's also possible that I could have an identical twin that shares my genome. So it isn't the genome that most defines who I am. The sense of myself, my memories, my personality, my personal quirks, the things that my friends and family and all my friends around this table think of as who I am reside in my brain, not in my genome, primarily. And so I think that when we begin an enterprise of trying to understand, diagnose, and manipulate the function of that particular organ, it is crucially important that we think about it deeply, and that's why I moved my professional attention from genetics to neuroscience and tried to help found this field of neuroethics. It's now been about a decade since the establishment of that field. It's grown tremendously. We have an international society. We have 2 major journals. We have all kinds of meetings now, but we've really only begun to scratch the surface. Most importantly, there's no ELSI project for neuroscience, no pot of millions of dollars to explore neuroscience research ethics, neuroscience social impact, or any of the other things that this powerful technology is about to release to us, on us, and for us. No such funding has been seriously discussed, as far as I know, for the human brain initiatives, or in the 90s with the proclamation of the Decade of the Brain, and none of the federal agencies have dedicated a large amount of money to that pursuit. So my first recommendation is that this committee recommend a reprioritization of NIH, NSF, and other federal agencies to take seriously the need to examine the ethics of neuroscience. It is at least as important, and I believe right now in some ways more important, than the work of neuroscience and genetics, something I'm very dedicated to, so I am not in any sense trying to minimize the importance of that as a matter of balance. There's no doubt in my mind that neuroscience policy is the next great challenge of technological policy in the United States. Technologies are coming down the pike that are challenging our sense of agency, selfhood, and privacy. They'll present and already presenting major conundrums in law and jurisprudence, and in fact, one of the only really major funding of a project in the United States around neuroethics has been around the MacArthur project around law and neuroscience. It will give intelligence and security agencies new tools that can be easily abused, will increase the public's concern, and I'll just an editorial comment here. Anybody who is in this field will know that my inbox is filled with emails from people around the country who are absolutely certain that they are being surveilled, that the FBI is beaming microwaves into their brain, that their brains have been manipulated. And the truth of that aside, it is a powerful part of the public's consciousness and belief system that as soon as security agencies and others are able to do these kinds of things, to have this kind of power, that it will be immediately released on the American public. And I think that part of the reason that that is so strong in the public is because we haven't done a good job. I'm constantly telling people, we can't do these things yet. But what about when we can? What do you say to them then? So there's not only the appropriate conversation, there's also the concern and in some cases paranoia, I think, around these things that we need to address. It will also raise questions about state-sponsored intrusion into civic life, something we're dealing with in other areas right now in our country. Will fascinate the military. It already has. They've given handheld lie detection devices to troops in Iraq and Afghanistan. And in their attempt to build technological warfighters, will prevent new questions of the boundary between privacy and commercial activity in stores, and on and on and on. So first of all, I want to say something about that challenge in relation to neuroscience education. So we teach responsible conduct of research, as we've said, but there's a more powerful area, and Mildred brought this up, in an exploration of what the impact is of science that people do on their greater society. We are now rewriting the book Responsible Science at the National Academies of Science. I'm on that committee. And one of the things we're doing differently from the 1992 version is talking about science aspirationally, not just regulatorily. That the new book should say something about what science should be, what science should aspire to. We need to encourage scientists to be part of that larger conversation. I think in all graduate science programs, and not just neuroscience, we have to challenge our students to confront big questions. There are certain questions mentors and educators of science need to revisit periodically and seriously with their charges. What is science for? What are the values I bring to my scientific work? Why did I become a scientist and why am I one now? What are the moral motivations, inclinations, and principles at the heart of my scientific pursuit? How do I advance the cause of scientific progress in a way that's helpful and productive? Whom does my research serve? What are the potential impacts of my science on my field and on society as a whole? And how can my science be misused, and how can I be an advocate for its correct use? The Dutch and European science foundations are both adopting a so-called socially responsible innovation research framework, under which researchers are expected to think about and forecast what sort of ethical issues their science or technology might create. They're also charged to build an ethical dimension into their projects, to explore ideas about how to ensure that those ethical challenges are properly accommodated. Socially responsible innovation programs should be part of the recommendations of this committee, part of President Obama's BRAIN initiative, in fact, part of the entire science initiative of our country. There are models of this type of program in other countries that we could look to find best practices and innovative ideas for assuring the highest level of thinking as we develop these powerful ideas and technologies. Neuroscience has been experimenting in areas that have profound ethical implications. Brain imaging research is inching closer and closer to an ability to apprehend subjective thought, something I've written a lot about. For all of human history, without exception, any information we ever got from another human being we got through their peripheral nervous system, whether it was expression or language or galvanic skin response, whatever it was. And now for the first time in human history, we can get information directly from the central nervous system, directly from the brain. This is a powerful technology. I keep thinking we're going to hit a wall and be able to go no further, and neuroscience keeps pushing through that wall to the point where now we can actually look into people's brains and know what word they're thinking of, what card they've chosen, what their intention is in the next few minutes. We are also developing lie detection, brain imaging.
Excuse me, I have to say something. I think that's playing God, and I disagree with that, and I need to make that statement. That is wrong. You cannot know what somebody's thinking, and you cannot know somebody's intention. That's playing God.
In another area of neuroscience, scientists have for the first time now linked two brains together, two rat brains first, and then actually a human and a rat brain, so that the activity of one brain affected the ability to behave or the knowledge of the second brain. Now these are, very preliminary experiments. They're not experiments that are going to be affecting the general population in any time soon in any profound way. But now is the time to think about their implications. Not once these kinds of technologies have reached the kind of power that they can be of concern to us in the general population. Something like a brain-to-brain interface open up whole new areas of possibility in communication, and we now have scenarios of even remote brain-to-brain communication that might even be able to be used coercively. I could go on with other examples. But the point here, I think, is obvious, and that is these are issues that are not only important for neuroscientists to think about, but for all of us to think about. And for that reason, I think the participation of neuroscientists in this conversation is crucial. They bring not only expertise, but they also bring a note of sanity as people talk about nightmare scenarios and science fiction scenarios, and I confront that everywhere I go. And every time I talk about these issues, people are concerned about these fantasies that they often weave about where this technology can go and the power of it. But those fantasies are fueled by real research and by real things that are happening now in the laboratory. So to end, I think that there are 3 or 4 things that this commission could recommend that are crucially important. The first is that reprioritization of federal agencies so that money can be spent in the way it was through the Human Genome Project's ELSI project, so that we can begin to think about these things more systematically. Secondly, encouraging a different orientation, as Mildred talked about, as all of us talked about, of graduate students and even of undergraduate and even pre-collegiate education around issues of neuroscience because of their increasing importance. And then the final one is to encourage scientists to speak publicly about these topics, because they are the ones who not only have the expertise, but have a right to advocate for the science itself, for the goals of the science itself, and for sane public policy around neuroscience. I think it's very important that we begin that process before neuroscience reaches a level of do-it-yourself. And by the way, one last thing, there are now do-it-yourself technologies that people are using in their own homes now to try to manipulate their own brain processes. So these are things that need to be talked about now. Thanks.
Thank you all.